Well, thank you so much, everyone, for being here today. As I mentioned, my name is Fernando Rocha. I'm a customer success engineer here at Diagrid, and I'm here with Alice Gibbons. Hi, Alice.
Hi, Fernando. Hi, everyone. Thanks so much for joining. My name's Alice Gibbons. I'm also on the customer success team here at Diagrid. If you haven't heard of us before, we are the company that is behind the Dapr project and are working on a ton of exciting solutions in that space. So thanks so much for joining.
Yeah, and Diagrid has a very cool mission, right? Our mission is to boost developer productivity by providing tools and APIs so you can build cloud native applications the easiest way possible, right? And that's what we're here to talk about. We're here to talk about how you can kickstart your Dapr development on Kubernetes, right? We're going to talk about how you can start that. We're going to talk a little bit about distributed applications, the challenges that you face when you start building them, and how Dapr helps you solve them, right? And the second part, which is the coolest part, is how you can take that to the next level, how you can use Diagrid Conductor Free, which is the free version of a product that's been around for a while. It was just released a couple of weeks ago at KubeCon Paris. How you can take that and boost your productivity a lot by using it when you're using Dapr environments. So either you're already using Dapr or not, or if you're building distributed applications, this presentation is for you. So kicking things off, let's talk about distributed applications for a second, right? And let's take an order system app as an example. When we're building a system like this in a distributed way, we have distributed services that have very unique responsibilities. We have an order service, for example, which can be responsible for receiving orders and sending them to a particular queue, any message broker that you want to use. We can have an order processor that picks up the messages from that queue, from that stream, and starts a workflow process with three different services. One service, we can call it make line service, that manages that particular order, manages the state of the order. It calls a receipt generation service that generates a receipt to our customer, and a loyalty service that updates the loyalty points. All of the services, they can have state store, where they can store their current state and keep things in check. You can have a scheduled task called virtual worker, for example, that can manage those orders and close these orders at a particular time, calling an API on make line service. And make line service can communicate that information back to the message broker saying that order is completed at a different topic, right? So a very simple application, as you can see, not a lot of services going on here, but still has a lot of complex intricacies that we need to be aware of. There are things that us as developers, we need to be aware of to build a well-architected solution, right? One of these problems with distributed applications, one of the challenges is managing service orchestration, right? How do I orchestrate the business logic between all of the services? How can I make sure that the order processor has the current state of every single service that it's calling, right? How can I make sure that it's calling it in a chained way? How can I make sure that if something fails, that I can roll back or at least tell that information to someone who is responsible for fixing it? How can I do distributed tracing? If I have all of the services here, how can I trace all of these requests across all of the services, across message brokers, state stores, making sure that everything is working properly, that I have the right requests, the right responses with the right RPS and a very low error rate, right? Probably zero if you're doing things correctly. And how can I configure access to these services, right? Thinking about security here, access control for a little bit. How can I make sure that, for example, the make line service can only be accessed by the services who need to have access to it? If the order service doesn't need to call it at any point, why should I have access to it? I need to be able to block it, right? And if you're doing things separately, you need to go service by service to do these things. Another thing is if something fails, if I have a very important thing that I need to perform, very important order that needs to go to the message broker, but that fails for some reason, how can I make sure that I'm able to retry it? How can I make sure that I'm able to hold it, scope it a little bit, transform it, and send it back to the message broker? I need to have that particular information, right? I need to make my application very resilient to be able to handle errors, retries, circuit breaks in a very comprehensive way. And that can be tricky if you have multiple services to worry about. And because of those reasons and many more, that Dapr was created, right? Dapr stands for Distributed Application Runtime. And the best definition that I've seen from it comes from Diagrid. We say that's a unified programming model that exposes application level APIs so you can build your distributed apps using best practice software patterns and practices, right? And that's the coolest part for me, at least, providing you with complete code portability, right? We're going to see how that works in a few slides. But the idea is that it facilitates for you to build the distributed applications across a cloud and edge devices. Okay, this particular project started in 2019 by our CEO and CTO, Mark and Yaron, and it was donated by the Cloud Native Computing Foundation in 2021. It is an open source product that has a very vibrant community today. Okay, and a couple of numbers for you here. We ran a survey, and with over 150 developers, and 95% of them said that Dapr actually saves them developer time. They are being faster in their development environments, building out their solutions and focusing a lot more on business logic because of Dapr, right? And stakeholders are seeing that 30% of higher savings in developer time using Dapr. So if you choose to add Dapr to your workloads, to your architectures, to your system, you're going to see some numbers as well. How does it work? All right. So basically, the idea of a distributed system, of distributed architecture, right, is that you want to pick and choose the best technology to do the service that you want. And that can mean different things, right? It can mean that sometimes you're building a service that is best written in Node. Some services are best written in Python or Go or Java or .NET. It doesn't really matter. Dapr allows you to pick and choose any type of language and runtime that you want to use to build your services. And what Dapr is doing is Dapr is using HTTP or gRPC to connect to your application, right, and provide a myriad of APIs for you to use between workflows, pub sub, service invocation, state management. We're going to see a few of them in a few slides as well. But the great thing about it is that talking about the developer challenges, Dapr already embeds out of the box for you some of the best practices that we see on software patterns around observability, security, and resiliency. We're going to see these pillars a lot during this presentation. And if you're working with Dapr, you see that all the time. Okay. And the idea behind is that you can host your application in any type of cloud provider or edge infrastructure that you want to. Okay. Azure, AWS, Google Cloud, we don't care. Okay. But the reality that we see today is that over 90% of production Dapr workloads are running on Kubernetes. That's why everything that Diagrid builds, we test it extensively in any type of cloud provider that has a Kubernetes distribution, right? To make sure that everything is working perfectly for you to use. I talked about the APIs, right? What are those APIs? APIs, they are distributed between a lot of different categories. We can pick pub sub, for example. Every single one of these APIs, they have a lot of components associated with them. Today, we have over 120 components available for you to choose from. And basically, what this does is it allows you to write your application connecting directly to the Dapr APIs without really worrying about clients and SDKs that are provided by the service providers. So if you choose to use AWS SQS for publish and subscribe, for example, instead of leveraging and embedding in your application the AWS SDK, all you will need to do is use the Dapr API and the component that's basically a YAML file that tells your application, that tells Dapr that in this particular case, you are using SQS as a pub sub service. Okay? If you want to change that to Azure Service Bus, GCP pub sub, Redis, Rabbit, and Q, it doesn't really matter. You wouldn't need to change anything on your application code other than the configuration file, the YAML file that tells Dapr which type of service you want to use. Okay. All of these components are open source. They are developed by the community. So if you want to create a component there, just open a proposal and it will be picked up. But how is this possible, right? How can I make sure that, all right, my application doesn't really care what type of service I'm using for pub sub, for secrets, for cryptography, for state management? How can I make sure that this is possible, right? So basically, this is possible because Dapr uses a sidecar pattern, right? And if you're not familiar with the sidecar pattern, what it is it provides another container or process that runs alongside your application that is responsible for a lot of things, but basically platform abstraction, proxy communication to other services, logging and configuration, right? So you never have service-to-service communication. Application one's never going to talk directly to application two. Application one's going to talk to the Dapr Sidecar through HTTP or gRPC, your choice. Then the sidecar is going to talk to the sidecar of the other application, and they're going to have that communication, right? So that provides you full, complete isolation of your environment. Only your sidecar is able to access your application at that time. Okay, and that's great because that says that guarantees that every single type of communication that we have is through localhost, regardless if you're running this locally or on Kubernetes. So there are no code changes when you move things across environment, making it very easy from move to test, from development to test to production if you choose. Right? And this is how it basically works. As I mentioned before, instead of having your application code calling using a client SDK or calling APIs that AWS provides when you want to use SQS, for example, you would just call a post method called publish, right? And that's an API that Dapr provides to you to communicate. So if you're calling publish on your broker inside a particular topic, it doesn't really matter. SQS, Redis, whatever you're using to store that data, to use it as a queue service, it's going to work without any code changes. So talking about the community a little bit, you might be thinking, all right, that's an open source project, right? I work at a big corporation, enterprise. How can I trust it, right? You can trust it for multiple reasons. But basically, first one, it's a very big project in the Cloud Native Computing Foundation, right? It ranks really high. It has a very vibrant community, a lot of GitHub stars, Discord members, contributors. We have a lot of people contributing on a daily basis to the project itself. You have Diagrid, which today is the home of Dapr, right? Making sure that the open source project is running smoothly. And you have a lot of contributing organizations other than Diagrid that back that project, right? So for example, Amazon, Microsoft, VMware, Alibaba, HashiCorp, and all of those that you see on the screen. So if you're thinking about, should I trust Dapr on my environment? Yeah, all of these companies, they back Dapr, right? So yes, pretty trustworthy in a production environment. Now let's get a little bit more technical here again. Let's talk about our order system like we were talking about before. So let's say we have the system. How would we build it if we weren't using Dapr? So we would need different clients, right, for every single piece of our application. If we choose, for example, Kafka as a message broker and Redis as our state management store, right, or key value store, we would need Kafka clients on the order service, order processor, make line service, because they all communicate back to Kafka. You would also need Redis clients on loyalty service, receipt generation service, and make line service, because they all communicate back to Redis. If you want to change Kafka to something else, you would need to change all of the clients in your applications. And you know, in an environment where we're always changing cloud providers, moving from one place to another, it's not unusual, right, for us to need to change a service from Azure to AWS, for example, or vice versa. So when you need to do that, you need to do a long process and project planning to change all of your applications to the new SDK, to the new clients, and you need to manage all of that separately. With Dapr, that becomes a little bit easier. With Dapr, what you have is you have a sidecar. You have a sidecar running alongside every single one of your services. And that sidecar is responsible for providing you the APIs that abstract all of them that need, right, of managing different clients and provide you that portability. So instead of using the Kafka client, you could use the pub sub API provided by Dapr, right? Your application doesn't care that you're using Kafka at this point, okay? Only Dapr needs to know that by using configuration files, components, right? If you're building a workflow, you could use the workflow API, right? Dapr provides that as well. That will help you manage the state between multiple services. Same thing, you can use the state management API to manage the state between all of your services and your key value stores. You can use service invocation from the virtual worker to the make line service to call an API that is enabled there. And then make line service is going to use the pub sub API to update Kafka at another topic with an order completed status or something similar. And you can use bindings, right? We also have that. You can use Chrome input bindings to run your virtual worker that's going to be completing your order at a regular cadence. So that's all great, right? Is it perfect? No, you still have challenges. When you are developing applications like this, you need to control a few things, right? So Dapr locally still needs a little bit of control so you can make sure that everything is working properly. As you can see here on the right side, the Dapr control plane comes with a placement service, an injector, sentry, and an operator. Okay, you need to make sure that all of them are working properly at all times inside Kubernetes, either local or in a cloud provider or whatever representation of Kubernetes that you're using, to make sure that your apps are working and can communicate with each other and can discover each other. So if you're doing that locally, you're going to need to depend on Docker Desktop, you're going to need to depend on Minikube, you're going to need to depend on Dapr CLI and all its dependencies to make sure that everything is working. You need to be able to follow development best practices, even though a lot of it is already embedded in Dapr as is. You still need to understand, all right, if I'm creating a component here, what is the best way to create this component? How can I make sure that this component is being created in a safe way, in a secure way, providing the best configuration possible that I have, that I can give? Dapr, again, as an open source project, right? It's a very live project. We have a very regular release cadence, but sometimes you have security updates or you have bug fixes, so you have constant versions coming out that support the community, right? So you need to make sure that you have the latest ones always, so you're able to test your application constantly with the newest versions. So you need to know when they come out. And you also need to be able to test apps with specific Dapr versions, right? Changing the Dapr version constantly to make sure that your applications are still working with the newest versions. So this can be challenging, and that's something that developers need to handle on their own, unless they're using Conductor Free. Conductor Free is going to do a lot of this for you out of the box, okay? It's going to give you optimal control plane configuration. You're going to understand everything that is going on your Kubernetes cluster that is Dapr related. It gives you installation and management for those pieces. It gives you automatic advisories for best practices. If you have something that could be configured in a better way, Conductor Free is going to tell you about that as a developer, so you can go and change it. You have version support notifications. If a new version comes out, all right, you know about it, you get notified, you can update, and then you can update with one click. Actually, you have one-click Dapr upgrades, right? New versions, release candidates, all of the new versions that come out, they are available in Conductor within 24 hours, and you can have you can roll out your apps after you upgrade it for testing in a very simple way, right? Now you've seen a lot of slides here. I want to show you a little bit what I'm talking about, how this would work in your environment if you were to start a new application, right? If you were to connect an existing cluster with Conductor. So the first thing that I would do here, let me show you currently the state of my cluster, right? So right now, I have a couple of namespaces here. I have Dapr installing Dapr system. I have Kafka running here on the Kafka namespace. I have Redis also installed. You saw that on our architectural diagram. And I also have a namespace called OMS here. That has all of the services that I need on my application, right? Loyalty, Makeline, order processor, all of them, they are here. Okay, now, if I want to make this extra robust, what I need to do is pretty simple. First things first, after you create your free account, right, on Conductor Free, you will see this page. And all you need to do is connect a new cluster. That process takes around 30 seconds. So what I want to do here is give it a connection name. I'm talking about my order system in this particular case. With a dash. I can choose a lot of different Kubernetes distributions here. As I mentioned before, Conductor is tested against all of these distributions. So you can choose EKS, AKS, GKE. I am doing things locally here on Minikube, so I'm going to choose local Minikube. For some of this, right, one of prerequisites for Conductor to work properly, that's in our documentation, is installing the metric server, right? Some distributions already come with it, Minikube doesn't, so make sure you let Conductor manage that for you, right? So you don't have to do that manually. Remember, we're trying to be more productive here. You can also let Conductor install Dapr, and that's a great thing if you choose to do so, right? One last thing for you to manage. And Conductor is going to install Dapr using best practices, right? You're going to add a lot of cool configurations for you so you can develop your application the best way possible without having to configure them manually after you install Dapr on your own. So I'm creating that cluster connection, sorry. It's going to give me a kubectl command here for me to use. All I need to do is apply. It's going to do a few things here in my environment. We'll come back to that later. And now what it's doing here is creating the communication between my cluster and Conductor itself, right? You can see that I can see very quickly here that a lot of the things are running already. My control plane status is healthy. My agent status is online. I have no issue so far. That's going to change. And I can see that it is installing Dapr for me. If you want to see how that looks on your cluster, clear up here a little bit. It adds a couple of namespaces for you, right? If you don't have Dapr installed yet, it's going to add a Dapr system with Dapr for you there, with all of the Dapr pods that are needed. You can see all of them here. And it's also going to add a Diagrid cloud namespace with a couple of things. Right, it's going to give you an agent, which is responsible for picking up the information from your cluster and sending back to Conductor. And another agent, but is responsible, this one's responsible for collecting logs and sending back to Conductor as well. All right. Oh. Now, okay, give a little bit of time. We have a couple of things to check here, right? So first of all, the first page here, the dashboard, you can see your cluster health on your cluster insights. You can see that your cluster is healthy or not. You can see that the Dapr control plane uptime here, everything's working properly. The current Dapr version, you could update it here if we have an upgrade. The agent version, if you have any critical metrics issues, high impact advisories. You would have application information here if you have error logs, critic metrics, or high impact advisories for you to work on. You would be able to see it as well. I have some components insights here. These are going to change a little bit once I sync things. But if you have any components insights, if you're connecting, if you have configuration files that are creating some problems for you, that would be shown here as well. You also have an application graph. Alice is going to go over this a little bit more detail for you, so I'm not going to go too deep into this. But basically, you can see how your application, right, how your services are connecting to each other, and with the components that they depend on. So I can see in this particular case that order service receives information from virtual customers, right, with a particular error rate or RPS, and it's communicating that information back to Kafka. All right, so I can see a lot of information here if you isolate it. You can get that traceability that we were talking about. You can get a lot of information here from this view. In Advisor, I need to sync advisories here. When you sync advisories, you're going to see all of the problems or possible things that you could do better in your environment, right? As we mentioned before, in those three pillars: security, reliability, and observability. You can pick and choose the one that you want to use. In this particular case, I have 3 advisories here. 1 is high and 2 are medium. If you don't care about a particular advisory, it doesn't need to be important in your environment. You can just dismiss it. It's not going to show to you anymore. But if you have a high one, you can click on it, right? In this particular case, component metadata contains sensitive information as plain text. I can click on it, see the problem, see a possible resolution for it, okay? I can go in more information and take a look at the documentation associated with it, right? And I can also see the component that is giving me issues. In this case, I know that the problem is on Kafka, and I have a clear text password here that I need to fix ASAP. Okay, so these are some of the advisories that you have. And this is great because it's going to tell you what is wrong with your application without having you to go and reading tons of documentation, right? It's right there for you to see, pretty chilled up. You know exactly what's going on. You also have your applications here, all of them that have issues or not, if they're healthy or not, their namespace, the amount of CPU and memory that they are using, Dapr version. You can go deeper into this and understand how they're going, right, from a resource perspective, CPU and memory, the usage. You can see a lot of information here that is very, very, very important if you are a developer and you are developing these applications. You can also see your components that you have deployed, the proper configurations that you have built, subscriptions, right? If your app has subscribed to PubSub, whatever, you're also able to see it here. Resiliency configurations, resiliency policy actors. So it's very comprehensive. What you see here is very detailed. And one great thing about this is that you're going to have a one-stop shop so you can see how your application is working. Okay, I talked a lot. I showed you like a good overview of what it does, what you can see on a free environment. And now I'm going to pass it over to Alice. Alice is going to talk about the fun stuff now. Alice.
Thanks so much, Fernando. Yeah, the chat has been very busy. So really great questions, everybody. I truly cannot keep up with them, so I apologize. But I will answer some of the other ones that I haven't got to either live or at the end. So yeah, if I haven't answered your question, it's not because I don't want to. It's just I haven't had time. Okay, awesome. So yeah, Fernando gave a really great overview of Dapr as well as some of the things that you can get with Conductor Free out of the box. I'm going to go a little bit more into some of the other challenges that you have on development and how Conductor Free solves those for you. Okay, so a few of the other things that I wanted to talk about here are specifically around the troubleshooting. So as a Dapr developer, especially for someone who is new to Dapr, you can. Is this actually, sorry, I apologize. I started on the wrong side. Yeah, the one thing I want to start with was the application and infrastructure interactions. So today in Conductor, today in Dapr open source, there's not an easy way to visualize the application and infrastructure interactions. There was the Dapr dashboard. If you guys are familiar with that, that was a little bit of a security risk for some people. And then, we have moved away from it within the open source project. But, it still is, especially for new developers who are new to Dapr, there's not really an easy way to see how your applications have loaded your components. As well, YAML resource creation becomes like one of your main jobs as a Dapr developer, and you are responsible for, checking these YAML files for misconfigurations, specifically of, component files, configuration files, of all the CRDs that you're wanting to use that, are representing your underlying infrastructure. In addition to that, the component validation is done at runtime. So I'm sure if you have experience in this space, you will have run into this issue before where your component is not correctly reaching out to the broker or the host name. This is a Kafka broker in this slide, but really whatever underlying infrastructure connection cannot be reached for whatever reason. And that you only find out at runtime. And then last but not least, just, breaking apart the two types of Dapr subscription. So there's like declarative as well as programmatic. And, sometimes it can be difficult and you have to dig through kind of logs in order to figure out which subscriptions are being loaded by your applications, as well as, what routes and rules those are using. So, how does Conductor Free help with this? We have a dynamic application graph that's kind of built directly within that product. You can kind of think of this as a new dashboard to kind of view your applications and your infrastructure components together. It also gives you the idea or the ability to see metrics right on there, right? So you can see RPS and error rate, as well as, your components and how they're connecting to each other, as well as to the infrastructure. We also have a Dapr YAML resource validation. So, today you can see all of the YAML components that you're using within your cluster, within your development environment. And we also have an in-browser editor, which is coming really soon. So I'm excited about that. Last but not least, the component errors. So, those errors I was talking about where, you're not able to connect to your underlying infrastructure for whatever reason. In Conductor, you can actually see those surfaced really easily within the UI. And then you can also get a deeper look into the subscriptions, whether programmatic or declarative, and see, which applications or which scoped applications are connected under the hood. So with that, I'm going to flip over to the UI here and just kind of dig a little deeper into some of the stuff Fernando showed. So you can see my Conductor dashboard here. This is a similar cluster. I'm in Conductor free as well. So this is the same free version that he was in. And you can kind of see within my cluster, I have a number of insights I'm going to get out of the box when that agent gets installed. He already went through some of these, but I want to specifically talk about some of the application insights. So from this page, you can see all of the different Dapr applications that are deployed on your cluster. If I'm a developer, I might not care, that much about like my memory and CPU usage, but I can also see things like the Dapr Sidecar version that's running within my application, as well as, if any of these are running or, the pod status not running, or if there's issues detected. I'll talk about some of the issues detected in a minute here, but I can also view these on a graphical view, right? And this is our applications graph I was talking about. And so, this is going to give me a really nice picture of how my system actually looks on Kubernetes, which can be difficult. And this, I should also mention, we're not actually using any sort of tracing or, distributed tracing data to build this. It's actually entirely built off metrics. So all you have to do is enable Dapr metrics within your cluster, and you kind of get one of these out of the box, which is really nice. If you take a peek at the legend down here, I can see both the service invocation and the pub sub call. So, whether my applications are communicating asynchronously or synchronously. I can kind of get a view into that. I can also take a peek, and isolate on applications and, see how, they are talking to each other and the components and the underlying infrastructure resources. So you can see here, this is the same application that we talked about before. So this is our order application, and we have a load generation service, which is called the virtual customer service, and it's publishing some messages, or it's invoking the order service via service invocation, which is in turn publishing a bunch of messages onto a Kafka message broker. We also have how do I know it's Kafka? I have the opportunity to, isolate on the message broker itself, and I can kind of see, what's going on in here. I can also exit out of this. Oops. I can also view, any of my applications that might be unhealthy. So, I have this application here, which is actually not running for whatever reason. I can quickly take a peek into that and just say, hey, what's going on? Looks like, I got 10 application restarts, no Dapr Sidecar restarts as of now, Dapr version, things like that. If I wanted to get into some of the other or another one of the applications here that is not running for whatever reason. In this case, it's called the loyalty service. It is a service in our order system that is in charge of keeping track of loyalty points. I can also view that in an applications view. So, jumping into a specific application within Dapr, I get a number of the attributes that I care about from the Dapr perspective. So things like, the application ID, I get, whether or not, the pod status and some Kubernetes things, but then I also get a number of these Dapr annotations. So this is just kind of giving me a view hey, what's actually deployed on my cluster, because looking through YAML files can be a lot. I can also see some of the CPU and memory resource usage out of the box. So, CPU memory, I can see that broken down by application or Dapr Sidecar in this case. You can also view this over different time periods if that's something that's interesting to you. But the main reason why I wanted to check this out was because this application was failing, right? So if I wanted to take a peek into this application failing, let's take a look at these metrics. So some of the metrics that this app has. These are actually produced by some of the default alerts out of the box from Conductor and Conductor Free, including Conductor Free. And so you can kind of see on this case, I have, this is in crash load back off. It's been in more than crash load back off for a couple minutes here. I wonder why it's in crash load back off. Maybe if I click on the components, I can see what components it's loading. This, in this case, is going to give me a little bit of a better idea. So I have, not only the ability to view the YAML file for, what's actually going on here, but I can also see if there are any initialization failures. So this is specific to that error I was talking about before, where you might not know exactly why your component is not initializing correctly. But say if you take a peek in Conductor, it's going to tell you a couple things. It's going to surface that error up to the user interface, the user here. It's also going to let you know whether it's idle or active, or like when's the last time this has been called. In this case, I think it's idle, mostly because it is getting that initialization failure and is in crash loop back off. So a little bit maybe of a red herring there. But then I also can see some of the metrics, and again, not seeing any right here, I think, again, because of the crash loop back off. But taking a peek at this, I can look at this and see, all right, what do I got here? Looks like I know that this Redis host has one extra R in it, so that might be something I want to fix. If I just hop over to my VS Code, I had a spelling mistake within my host name. Of course, there can be many different reasons why the initialization errors fail, or the initialization errors happen. I would say, like most of the time, right, it's some sort of like either misconfiguration, metadata properties wrong, version is using an old version of the spec, something like that. But you only really notice it when your application starts like failing. So just kind of getting a better view into that. So let's see if I apply this guy. That's this one. And then, we should see, okay, so that's configured. That's good. I'm connected to the same cluster that I was looking at in Conductor here. Okay, and look at that, sweet. So it's initialized already. That's awesome. So it should hopefully get rid of that error, which it has. And then, shortly I should see some of the new metrics kind of popping into the user interface there. So if I look at the pods, so again, this is the same application that Fernando had deployed there. You can kind of see I still have this pod was in terminating. Okay, now looks like it's in running. Yeah, okay, so this one looks like it's the new one. So if I take a peek at what this looks like, and let's, of course, like you're still going to want to look at some of the application logs and the sidecar logs. Like you're not going to completely get out of that, but it allows you to, okay, nice. So we're back to having, oh, that's the service. There you go. Okay, there, we're back to having some order summaries in here. So at least we're back running. That was just, that was just a minute ago. So at least that is up and working again. And again, I should see some of the notifications in here as well. So yeah, what we are pulling by default is the fatal error and warning log messages from the Dapr sidecars. So within your development environment, if you don't care about, info and debug messages, you can just see by default all of the fatal error and warning ones in Conductor. That was kind of a quick overview of the component initialization. Some of the other things you can see are like, for instance, if you have resiliency policies within your cluster, maybe you're like, hey, I don't know if my resiliency policy is firing. I can view the activity status on it if it's been active recently. I can also see, that YAML specification and, what scopes or what applications it's actually scoped to. I can also view any subscriptions. Actually, let's back to this one. I can also view any subscriptions that I have, right? So, as I mentioned before, we have both the declarative and the programmatic subscriptions within Dapr open source. And this is great from a developer perspective because it allows you to either, define your subscribers via code or, via a templated YAML file. But it can be confusing when it comes to, what is defined where and kind of like who is actually subscribed to what. And so you can kind of see in here in Conductor, it gives you a view into, hey, I have 2 subscriptions. One of them is a programmatic subscription for, in this case, it's the order processing service. And then I also have the declarative subscription as well on that same service. And then I can also view that, full YAML spec, just like you can with all Dapr resources, giving you, some of the configuration, like maybe you enabled bulk subscribe, maybe you have a different route that is a routing rule that you might not have initially known about, things like that. And then, last but not least, I guess configurations. So if you're not familiar with Dapr configuration, these allow you to get super granular in terms of like, specific applications being allowed to use new features, or, pointing to different tracing addresses, things like that. So I can see I've created this one. In this case, it's for the loyalty service, and I'm enabling that hot reload feature. And that's actually why I was able to apply that component, and then it reloaded automatically for me without me having to go in and restart. It's actually a new feature in Dapr 113. It's in preview, and it will be in it'll be available in 114 fully, like not in preview anymore. But yes, so just if you want to, see which applications are using what, again, I can also see, hey, the loyalty service is the application that is scoped to that config. Whereas, I have a ton of other services that are scoped to my main config, right? Which is doing stuff like, has some metric rules in here. It's, sending stuff to Zipkin or my tracing, things like that. That was a quick overview. I'm just going to head back to slides for 1 minute. So a couple other the challenges I wanted to go through around troubleshooting, right? So I kind of saw this a little bit, with the component initialization failure, but troubleshooting in Dapr can be very time consuming. From a developer perspective, devs are supposed to get really deep into Kubernetes and infrastructure and kind of like bridge both of those gaps to kind of figure out what's happening. There's also not a ton of insights. Oftentimes people aren't spending a lot of time like making graphs and things for their dev environments, right? That's not like necessarily something that people are doing. It's usually those graphs and that effort goes into production or higher level environments there. And then also, figuring out which metrics to kind of alert on or which metrics are important from a dev perspective, I would say is really difficult. And then, last but not least, if you are an actors user, which is a very, very, very common API in the Dapr world, it's really difficult to get visibility into that in particular. We have a ton of users who have given us this feedback, like on the Dapr open source side, or like, from on the Diagrid side. And really just around, how do we figure out which metrics to alert on, or which metrics to view, and then like how do I know where my actors are in terms of what pod they're in, what where my actor instances are deployed in the placement table, things like that. And we're working on that. So with Conductor Free, some of these are mitigated. You have, like I said, the default alerts that kind of come out of box from a development perspective. Now, of course, you're always going to have, noise in your dev environment. Not going to say that's kind of normal, but things like crash and back off and things like these high Dapr error rates are usually not something that you want even in dev. And it just allows you to figure out some of these issues again sooner, and kind of shifting left that error discovery and resolution. We have a number of pre-built Dapr monitoring dashboards. So, 15 different graphs are per application. So you can actually see, which applications are causing which error rates. And that's like both across gRPC and HTTP API protocols. So if you are, using like the Dapr SDK, typically that is through gRPC. Or you also are taking advantage of the HTTP APIs as well. So kind of giving you visibility into both. Also a number of default alerts, like I mentioned that, and then for things like application component error rates too. So having alerting based on the infrastructure is a really nice thing, and like being able to bring that together with some of the other developer metrics is very useful to people. And then, insights into actor usage. So you can kind of see on the side here, I just tossed in a graph. This was from one of the workflows, which will show, but, being able to see, those are like for reminders or for timers, if you're using those, where they're firing, if they are getting errors, being able to see that just with default graphs is very useful to people. So let's see that again. I'm going to head back. In this case, I'm going to go to, I'm going to start at this applications page again. And this is, these are these insights I was talking about. So insights is the idea that, there is something not quite right with your application. In this case, this is one of my demo actor clients. And, if I hop in here, I can see based on some of the default alerts that are popping up here, this is just in crash and back off. So this application is just crashing, similar to the loyalty service was before when that initialization was failing. But, this is just going to tell me, hey, this is in crash and back off. And it's going to give me a little bit more information in terms of the pod and the message that has been the last message, I should say, that has, or the last event in Kubernetes that has been raised within that pod. And you can also see that it's the application that's crashing, not the sidecar. You can see the sidecar health is actually fine there. As far as the other one goes, so let's take a peek into this receipt generation service. So this is going to give me a few other issues, or it should, based on this. And so again, this is looking at all of the default alerts in the past 1 hour that have a critical metric severity. Now, there's lots of if I, clear some of this, I can see some of the other logs. Like if I, pop this open, I can see, metrics. I can also see some of the Dapr Sidecar logs. Again, these are all of the Dapr Sidecar logs that are warning, fatal, and error log levels. Just kind of viewing anything that's kind of most important. But, this insights in particular is just going to show me the most critical, the most recent kind of filters based on these metrics alerts. So, taking a peek into here, I can see that this one is telling me that my component error rate has been more than 0% for 2 minutes. So this component error rate is a metric from, the infrastructure components. So if I click on this, it's going to link me to the graph itself. You can see, based on the data that actually this receipt binding is actually failing, and it's been failing. Yeah, it's been failing for quite some time. So I think I have, just like a 5-minute time span here. But, if I take a peek into how long this has been going for, it looks like, okay, it's been failing for, about 45 minutes based on this. So that's maybe something to look into. The other thing I can look at, so if I head back to, metrics and then look at that past 1 hour, the other one I can look at is this application to Dapr gRPC error rate. So this is another default alert. So I didn't set any of these up. This was like set up by default for me in my organization. If I click on this guy, it's going to show me some of these throughput graphs that you get out of the box. And, lo and behold, it's also an invoke binding one that I can kind of see here. So if you remember, the other issue was around the component binding. This is also around, invoking that binding via gRPC. So kind of like 2 different metrics that are coming from the same root issue in this case. I can, also do some filtering. But one of the things that I might want to do here is like I kind of said, is check the logs, see if there are any logs from the conductor that, give me an idea of like maybe what's going on. So I have a lot of these in here. And then, at this point, like if I can't find anything that's like coming right up in the logs, then I know, based on the most recent metrics alert, this was in particular, this was the operation create for the receipt binding. So let's just take a peek at that for this one. And then we can also take a peek at the we can also take a peek at the Dapr Sidecar, right? So this top one on the top I have is the application, and you can kind of see, hey, I'm getting a ton of logs within the application. So we don't collect application logs within Conductor, just Dapr Sidecar logs. So this is telling me, hey, invoking output binding. Binding is missing the key in the request metadata. So this is a specific to how I made that call to that output binding. On the bottom, this is also telling me similar thing, right? Error invoking output binding. And I have the Dapr dlogs in debug mode, which is why you're going to get a ton of the verbosity on the bottom. But yeah, so again, just being able to see like where these are initially coming from Conductor, and then kind of be having, the empowering yourself to kind of take a deeper look into kind of what's going on behind the scenes there. I guess the only other thing I didn't mention was just the actor insights. And I didn't just want to show these really quickly, but essentially if you are an actor user, like I said, it can be really difficult in Dapr to see really what's going on from an actor's perspective. And this is why we have a full actors tab in Conductor free that allows you to view all of your active actors and see how many active actor instances you have, as well as if you have them on which pod. So I can see which pods these are running on and where this instance is, which, if you know about the placement service, is handy for debugging purposes. I also have a number of bunch of graphs around the invocation rate. So this demo actor has been invoked. This is the rate as it's being invoked over time. And then I also have if there's any errors in those invocations, so any methods on that actor that are failing. And then I also have any if this actor is using timers, and so have these timers kind of been fired? Yes, looks like they have. No errors in the timers. And then there also are some reminders. And last but not least, you can also see any reminders, errors in this case as well, which is kind of interesting. So just kind of some details into actors there, and I just want to pass it back to slides for one more minute, and just kind of show this last slide. So, thanks everyone I think we have 5 minutes left, and I see there's a bunch more questions, so I want to get to some of those. But, just before we hand it over here, feel free to sign up for Conductor free. It's completely free as it's included in its name. And check it out. If you are a Dapr developer, I don't really see a reason why not to use it, especially from a, Kubernetes environment perspective. Within your development environment, you can connect your cluster. It takes less than a minute, as Fernando showed. We also have some really good resources around learning Dapr. If you're interested to hear more about what Diagrid is doing, you can always subscribe to the newsletter. I'll keep that link up here as well. And last but not least, we also do have a Diagrid Discord. This is a newer thing that we launched, but wanting to kind of support people out around our products, especially as a free product like Conductor free. And so feel free to join the Discord as well.